Hi everyone, welcome back to another Chem Corner. You are going to the place learning chemistry the easy way. Today, we are continuing our basic chemistry series where we simplify concept and build your foundation step by step. If you're new here, don't worry, the full playlist for this basic chemistry series I'm pinning here. So, don't want to waste the time, let's get started. In today's episode, let's see what is this polarity. What is the polarity concept? Okay, so before that, let's see what you mean by this covalent molecule. Okay, so hydrogen. Hydrogen, one electron is there. Another hydrogen atom is also, they also have one electron. Like every atom is, hydrogen atom is one electron. So they need one more electron because hydrogen, they want to mimic the helium, which is the nearest noble gas. So if two electrons are there, they would stable. Okay. So for getting that doublet, what they want to do? If someone is there to donate electron, they will accept that one. But here, just imagine if there is nothing, no one is there to donate electron. So definitely, they will share with each other like that. You may study it. But actually, is it really sharing? It's actually not sharing. Okay, both are needy. Since both are needy, both are dragging their electron, the other's electron. Okay, so we can say this is Ha and this is Hb. So hydrogen A dragging the hydrogen B electron and hydrogen B dragging the hydrogen A electron. Got it? That is actually happening. There is nothing sharing. So everyone is like greedy. So everyone like these hydrogen actually drag the other hydrogen electron. If both are same capacity, like this dragging capacity is same, what we feel? We feel it's like a sharing because the electrons are it's exactly shared. It's look like it's exactly shared in between the two atoms. Okay, because dragging like a tug of war. If both are same like same in energy, what happened? It's look like that thing is not moving. So this is actually exactly happening here. Right. Now let's see with the two different person. So one is hydrogen and another one is chlorine. Now you think about the dragging capacity. Hydrogen is one electron, chlorine with a seven electron is there. So chlorine also need one, hydrogen also need one. So what happened? They will drag each other. This time, do you think is it a like a equal strength? No, the dragging capacity is different. Okay, actually, chlorine has higher dragging capacity than this hydrogen. So, what is this dragging capacity, which is chemically called electronegativity? So, you can say chlorine has higher the electronegativity than hydrogen. In this HCl, what's happening actually? The sharing is not like equally. What happened? The electron is slightly shifted to the chlorine side. So you can show like this. An arrowhead is there. It's pointed towards the more electronegative atom and the other side have a positive side. Like this is the positive side. Okay, which means electrons are more in the vicinity of chlorine so that they got a partial negative charge and hydrogen got a partial positive charge. This is what you mean by dipole or otherwise called polar. Okay, di means two, pole means two end with a different charge. Okay, that's it. That is the concept of polarity. So where what are the things? So see the electronegativity values. So polling scale is there, like polling who's the scientist given the values for all these elements. So let's see how polling explain this polarity concept. So see if the electronegativity difference between the two atom, okay, electronegativity difference between the two atom, ah, it's less than zero point 0.4. If it's less than zero point 0.4 means nothing, right? A very slight difference is only there. So at that time you can say which is non-polar. Okay, which is non-polar. If it is there like sufficient like zero point 0.4 to 1.7, then you can say it is polar. What happen if it is greater than 1.7? the electronegativity difference between the two atoms, if it's greater than 1.7, which means one is highly electronegative, like one drag the more. At that time, the electron is completely go to the one atom. So at that time, the partial charge is not there. There will be a complete full charge. Is that called ionic, right? That is actually our ionic compound. Okay. For example, so see the sodium. You can see the sodium. If one atom is sodium 0.93 and the other one is chlorine. So what happened? Na is there like 0.93 capacity. Dragging capacity is just 0.93 is only there. But chlorine, the dragging capacity, see the dragging capacity 3.16. So what happened? Chlorine dragged the electron fully. So it looked like sodium is given to electron to chlorine. Actually, chlorine dragged the electron. So now the full electron is in the vicinity of chlorine. So it's look like a fully evolved positive charge is here. Sorry, negative charge is there, and fully evolved positive charge is there. Okay, this is nothing but ionic. So in this way also you can explain how ionic compounds are there. Okay, so non-polar, polar is what we called covalent compounds. Like both are covalent, but you can again divide it into non-polar covalent and polar covalents are there. Okay, because these kind of range is there. The problem is they were not provided this Pauling scale. So how do you know which is ionic, which is polar like that? Right? That's the problem. So you can say this difference. So this difference will be there whenever there is a metal and non-metal is there. Okay, whenever the two elements is metal and non-metal, definitely their electronegativity difference between the two thing will be greater than 1.7. So you can say ionic. Okay, so how do you know without the Pauling scale? So generally you can say if two elements are there, like one is metal and the other one is non-metal, so do not want to think about the values, you can say which is ionic. What about the polar or non-polar? How do you know it's polar or non-metal? Every homodiatomic element. Every homodiatomic. So homodiatomic means same element, like hydrogen, same element, chlorine, Cl2, like same element. So homo and diatomic means two atoms. So homodiatomic will be non-polar because same, right? So electronegative difference will be the thing is 0. So non-polar. Every heterodiatomic, generally you can take every heterodiatomic elements are polar because two different atoms, so definitely they have the difference in their electronegative value. So every heterodiatomic elements are like molecules are polar like that you can think, except non-metal, like both should be non-metal. Okay, but think about CH bond. Carbon hydrogen bond is non-polar. Just you can study like that in that way, like except CH bond. Okay, because see the values, carbon 2.55 and hydrogen is 2.200. So the difference will be less than zero point 0.4. So CH bond is non-polar. Even though it is like two different atoms, you have to consider like a non-polar molecule. Okay. But the problem is we are not considering like a whole thing. CH bond is non-polar. Okay. But I'm telling you CH bond is non-polar or other hetero atom bond you can consider like polar. Okay, every other two non-metal bond you can consider like a polar. Now, the problem is, okay, if it's so, can you tell me CO, is it polar or non-polar? What I told, every non-metal, different atom will be a polar molecule. Okay, so this bond is definitely polar. Oxygen is more electronegative, so you can show like this. This is polar. Then my question is CO2 is polar or non-polar? The problem is CO2 is look like the linear shape, right? So this is the way. So here, this is polar like this, and see here also the polarity is there. Okay, So in this way, both polarity is cancelled out because it's a vector quantity. So see, it's same and opposite direction. So the net polarity is zero. Net polarity is zero. So you can say this molecule as a whole is non-polar. Okay. So that's why even it contain polar bond, which doesn't mean the molecule as a whole, it's polar. Okay. So there is two things, bond polarity as well as molecular polarity. So here bond polarity is there, but molecule as a whole, molecule polarity is not there. Okay. Now let's see. What about SO2? SO is again, so see different atom is there. So definitely it's polar. Again, oxygen is the more electronegative atom. So this one is polar. Okay. What about SO2? SO2, so see, can I write like this and this one? This is polar and non-polar like this, same like a CO2. Ah, that's the problem. Here is the problem. Why? Because sulfur dioxide is not linear in shape. We studied about the shape, so you can check that video. How do we assign the shape? SO2 is a bent shape because there is an extra lone pair that makes the shape is bent. So that see, here it's polarity, here it's polarity. See, do they cancel? No, they are not cancel each other. So there is a net polarity in in this direction. Okay, so here both bond polarity as well as molecular polarity is there. Okay, so maybe the doubt you have, is it required for every time do I wanted to need to draw the shape and have to draw the arrow like this? Ah, not needed. Okay, there is an easy way. So how do you know a molecule polarity? How do you check the molecule is polar or non-polar? First step, again, have to draw the Lewis structure. Okay. Then check the central atom. Again, check the central atom. If the central atom with the lone pair, central atom with the lone pair usually polar. Okay. And another one, symmetry is there, that is also, sorry, asymmetry is there, that is also polar. These are the two conditions. First, draw the Lewis diagram and central atom with the lone pair or asymmetry is there, it will be polar. Okay, so let's see. So as we told here, sulfur dioxide. So why CO2 is, so see when you draw CO2, this is the Lewis structure, but SO2, this is the Lewis structure. So see, this lone pair make the molecule polar. Similarly, what do you mean by asymmetry? For example, CH3F. So see, carbon with the 3 hydrogen atom is there and one is fluorine. So see, here you can't see any lone pair on the central atom, right? Nothing is there in the lone pair, nothing is there in the central atom. So which means is it non-polar? Ah, no. Here what is the problem? It's asymmetric. So here a slightly polar, not want to draw the polarity in CH4, but because CH bond is actually non-polar. Okay, so that here non-polar, here non-polar, here non-polar, but fluorine is more polar, more electronegative than carbon. So there will be a net polarity. Okay, so this is happening. So that's why we are telling asymmetry. So CH3F, one is fluorine, not hydrogen. So if this kind of asymmetric molecule or central atom with a lone pair, you can consider like polar. In that easy way, quickly you can tell the molecule is polar or non-polar. Okay, and that's it for today's episode. I hope you found it helpful and easy to follow. Got any questions or topic you would like me to cover next? Drop them in comment below. Don't forget to like, share, subscribe for more simple chemistry lesson. See you next one. Until then, keep learning and stay curious.